Like theme music.
Minecraft.
Da 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 da. Adam, you got? Is that my intro? That sounded cool. Da, da, like graphics, like a piece of macaroni and cheese floating across the screen, and then like my face eating it. Somebody who goes into after you guys graduate in 5 years, someone in graphic design come back, design it for me. Okay, voice off. So 3, 2, 1. When you guys graduate in 5 years, or it's actually that would be 4 years. High school. You're graduating high school in 4 years. 1, 2, 3, 4. Yeah, I can count. Yeah, 4 years. You guys are gonna get a graphic design job because you're that smart. You don't even need to go to college. You'll come back and design an intro for my videos. That's it. So you guys, I bet I'm not really supposed to do this, but oftentimes when you guys are taking the cast, we'll just like peek over your shoulder, and it tends to be every single year. They throw for the performance task, which you'll take on Tuesday next week, this insane problem that has volume, but then it's like a word problem where you have to dissect the volume and add all sorts of other shapes in with it. And it tends to be the hardest problem that you'll encounter on the CASP. And today we're going to hash out what those look like. If you're a little bit like confused halfway through and you don't get it, just hang with me, because even if you can understand a slight part of it, chances are you'll get some credit or partial credit for the performance task, which could push you towards grade level if you get some of it right. So before we dive into it, though, we're going to review what all these formulas are and the why behind them. Cylinder is the easiest one, in my opinion. You have this area of a circle, which is pi r squared, and then you're kind of stacking all those circles up on top of each other, and that's where you get the height. Pi r squared height is the simplest one we did on Friday and Thursday. For a cone, it tells us it is 1/3 the volume of the cylinder. You guys watched a video where they poured the water from a cone into the cylinder, and it was 3 times that cone. So you have 1/3 of the exact same formula for the cylinder. And for a sphere, you have a half a sphere to the left. And you guys have already written this, but we're writing it again so it can get stuck in your memory. Board of paper, if you don't have this, please write it. The half a sphere, they tell us, is 2/3 the volume of the cylinder. And remember that when you go vertically from the center of the sphere, it's the same thing as going horizontally, and you're actually finding the radius. So you're not getting the height for a sphere, you're timesing radius squared times radius to the first, which just turns into radius cubed. The most common mistake on these types of problems is the r squared gets placed into a sphere formula, and students often forget that it should be a 3. That's why I'm going to continue to harp on it until we take the CASP. If I wanted to find the volume of a sphere, well, a sphere is how many times a half sphere? Jasper?
2.
It's 2. So 2/3 plus 2/3. I'm going to double this number. You could also write this, the way I like to think about it and enter it into a calculator is to divide everything by 3. This would also work. Jasper, a question? Where? Yeah, that is a blender. Multiply by 4, then divide by 3. Next page. Check your voice. 3, 2, 1. So this is a reference sheet for you. I'm not promising they'll have some reference sheets for you on the cast. Sometimes they'll choose to give you some of the formulas. Other times they won't. So today's work, if you need to glance back at these, that's fine. But your goal should be to try to solve these from memory as much as possible. Just these ones. So just the ones we focused on. The other guys, we didn't do the right triangular prism. We didn't do a rectangle prism. We haven't focused on trapezoids. They should have these ones for you if they do throw them on the test. Yeah. Let's dive into it. Example 1. You can't. You cannot. Example 1. Pablo's icy treat. Pablo's icy treat stand sells homemade. Pablo's icy treat stand sells homemade frozen juice treats as well as snow cones. Originally, Pablo used paper cone cups with a diameter of 3.5 inches and a height of 4 inches. His supply store stopped carrying these paper cones, so he had to start using more standard paper cups. So these are truncated cones. Truncated, underline it, means cut. Hayden Zion, I need a hand. Truncated means cut. They're cut cones that have this pointy end sliced off. The top diameter is 3.5, bottom is 2.5, ND first, and a height of 4 inches. So our goal is to say if this is accurate. Pablo put up a sign that stated the new cup holds twice as much water. Underline that. Is his sign accurate or not? Our whole goal is to find out if this is actually 2 times the distance of this thing. To do that, we need to find the volume of both cones, the truncated one and the one with a pointy end. Let's start with this one up here. The volume of a cone is 1/3 pi r squared times height. Write that formula aboard the paper. The radius for this thing is half of 3.5. 1.75 is the radius. And times the height of 4. We're going to get this thing in terms of pi first. Let's plug it in. 1.75 squared. Does that look right? No. 1.75. 1.75 squared equals 3.0625. Let's multiply that by 4. And divide it by 3. You could multiply by 1/3, but whenever I have a fraction, I think it's easier to divide. Okay, so this thing equals 4.08. Let's round to the nearest hundredth. Pi inches cubed. If I wanted to find the actual decimal number of that without pi, what do I need to do, Deacon? Yeah, 4.08 times 3.14. What would that be? 4.08 times 3.14? There's the volume. We're going to save this for later so we can compare it. Next, let's go to this truncated cone. And we need to kind of fill in this part because I don't have a formula for a cone that's sliced off. So draw a dotted line to make this end that was cut off. And just bear with me. We're going to say that's the cone. It says that they sliced 10 inches off. So from here to here, Andy, row 4. So this is 10 inches. 10 plus 4 is 14. Keep that in mind. And we're going to just write that out here. Okay. First thing we're going to do is we're going to find the whole cone. The whole cone includes that portion that was cut off. We're going to plug it into 1/3 pi r squared. The radius of the cone is the same thing. It's half of 3.5, 1.75 squared. And then the height of the entire cone is 14. There's the formula. Start plugging it in. 1.7 squared times 14 divided by 3. 1.75 squared times 14 divided by 3. Let's get both answers again. So 14.29 pi, or give me the other number if you have it. And what's my label for this one, Elise? 3D is always cubed. Okay, we're gonna save this for later, because we also need to figure out the portion that was sliced off the 10 inches height. And to do that, I need to find the diameter, and their diameter, they told me, was 2.5. So my next goal is I need to figure out what is the whole volume of this smaller part. So the volume of the smaller cone is going to be 1/3 pi. Radius is half of 2.5 times the height. Well, what's the height of this one? What number? 10 inches. Okay, so that's going to be the smaller cone that was cut off. Let's start plugging it in. 1.25 squared times 10 divided by 3. 5.21. We're going to round up. Pi, or give me the non-pi number. Okay. So what did we just do? We just found the portion that was sliced off the bottom. We have the whole entire cone to the left. What do you think I do with those two numbers if I just want the truncated version? Zion. It should be cubed. Thanks. It is. Yep. Not area. Kendall, you can mark one. Squared, cubed, cubed. That works. What do I do next? Hayden, just let her do her job. Because I cut this part off, I'm going to have to subtract the entire cone, 44.87, minus the part we removed, which is 16.35. When you subtract this portion and it's removed, the top is left, and you end up with what number? Thanks. There is your answer. But we're not done. He says the new cups hold twice as much. Is his sign accurate? If he wants the sign, Hayden, that's your second. If he wants it to be new, if he wants to know twice as much, we need to divide the new amount by the old amount. So we just found the old amount at the top, that was 4.08 pi. Let's write that in terms of pi first. Bless you. And then we're going to divide it by, did we do something wrong? 4.08, oh, that's why. 5.21 pi on the bottom. And divide it. Hold up, reverse. The new one is the bottom one. So you guys got a decimal version that was not 2. Erase that, put 5.21 on top. Divided by 4.08. Divide that one, see what you get. And again, you're first. Stop. Stop. Hold up. There's blunders on this one. So why isn't this 5.21? Someone catch it. This is not 5.21. Emma? It's not the new one. This is the portion that was cut off, right? The 5.21 is the red part. So if we want to actually find the pi version, we would have to subtract 14.29 pi minus 5.21 pi. So we only found the non-pi version, but we need to also subtract the pi version. So 14.29 minus 5.21, let's do that real quick. Yeah. 14.29 minus 5.21 equals 9.08. So we didn't do it wrong for this part, but if we want to actually work with the pi version of the number, we need to add 9.08 pi as an option. So this could be 9.08 as well. Add that below. And now we're going to divide. So it's 9.08 pi divided by 4.08 pi. And plug it in. And what's the answer? Emma. Divide 9.08 by 4.08.
I got 2.2 and then it keeps going.
So if he says the new cup holds twice as much, is that an accurate sign? Turn and talk to your partner. Does it hold twice as much?
So technically it's not like it's wrong. It's wrong. It holds more than
Yeah.
All right, 3, 2, 1. Ava F, what did you and Kendall talk about? You agree or do you disagree with that? You think it's accurate because why? It's twice as much and it's more, so they're giving like a bonus 0.2. It is twice as much with some extra. Anyone disagree with that? Anakin?
He said 2, not 2.
He said twice. So you could also argue that this isn't accurate because it's not exactly 2.2. He would have to put on his sign, this new cup is 2.2 times as much accurate, which I would accept either one. For the cast, when you get to the performance task, there's going to be a lot more writing, and they will give you points for just your arguments and your logic and your thinking. So there's a chance that if you did all this math correct, you got close to full credit and you have to explain yourself, you could probably get points for either a yes or a no statement, as long as you have all the work shown for these ones. Performance tasks are going to have like step 1, step 2, step 3, step 4, A, B, C, and then you have like the final like statement for what you think. All the work really and the points are going to be from this portion. So it's not so much finding the answer, they want you just to show them the steps of how to get there. Anakin.
So during it, you could be like, I disagree because if you're on a diet and you only want it 2 times, you didn't want 2.2 times.
Sure.
Then you can get sick.
Sure.
Yeah.
Next page.
Yeah.
2 glasses are shown below. The measurements are given in centimeters. Part A wants to know which glass holds more liquid. Part B, if the second glass was half full, how high would the liquid be? Is there a part C to this one? Nope. Great. Let's start out with the cylinder. That one's the easiest. Charles, what's the formula for a cylinder? Okay. They give me a diameter of 5. What's the radius, Charles? Okay. Pi times 2.5 times 6. Let's get the answer in terms of pi, then we'll get the other answer. 2.5 times 6. 15 pi. 4.
Wouldn't you have to square 2.5?
Thanks.
Go, baby.
That's 15 squared times 6. 5 squared? Where is 15?
No, it's 2.5.
It is 2.5. Thanks for catching it. Okay. 2.5 squared times 6. Plug it into a calculator, raise your hand when you have it. 2.5 squared times 6. Indy? I'm going to pause you. 2.5 squared times 6 is what, Addy? 2.5 squared times 6. 37.5 pi. And give me the answer without terms of pi. Julia. And label it. Centimeters cubed. Okay, there's the cylinder. Now let's find the goblet. For the goblet's the one on the right. It's kind of curved. And what you need to do is visualize this thing is cut kind of right here, where it says 3. And that cut off portion is going to have like a rounded top. And when you look at it, it kind of looks like a half sphere. So we need to find the cylinder, which is the top portion, and then we need to find the half sphere. Let's start with the cylinder. Anakin, what's the radius?
3.
Times the height of 3. We'll find in terms of pi first. 3 times 3 is 9, times 3 is 27. 27 pi, or 27 times 3.14. Caden, what is it? And label it for me, Lucy. Okay. Let's save this for later. The half sphere is down here, and the volume for a half sphere is 2/3 times pi r cubed. Indy, what's the radius for my half sphere? cubed. 3 times 3 is 9, times 3 is 27, or enter 3 to the third power in your calculator. 2/3 times pi times 27. I'm going to do 27 times 2 and then divide it by 3 to get my number. 27 times 2 divided by 3. 18 pi. You could also cross cancel. These numbers are easy enough to do in your head. So 18 pi is in terms of pi, or give me the non-pi number, Zion. 18 times 3.14 is what? Let Zion think.
56.5.
Centimeters cubed. Okay, so we have 2 parts of the goblet. What do I have to do to find the full goblet? Hayden, what? I'm not going to count that. That's a lame one to end on.
What?
It's lame.
Really?
You'll find one later. So what do I have to do if I want to find the whole goblet, Julia? I found the bottom part and the top part. What do you do to get the whole thing? 84.78 plus 56.25, or 18 pi plus 27 pi. We'll do both. It's going to be 45 pi, or 84.78. I'm going to add the label it later. 84.78 plus 56.52. Give me that number. Yeah. So think of pi kind of like a term, like an x, and if you add x plus x, it's like 2x. But if you have 45x plus x, it's just gonna be like the term that it is. So we added 45 pi or 18 pi plus 27 pi. The pi stays the same. You don't add another one onto it. So if you had like 2 pi plus 3 pi, you would get 5 pi. It's the same thing as 2x plus 3x equaling 5x. Does that make sense? Uh, 84.78 plus 56.52 is what? Help me with the answer. Emma? 0.30?
Yeah.
30. Okay. That's centimeters cubed. So there's the whole goblet. There's the whole cylinder. Let's compare it. 117 versus 141. Yeah. No, that's a lame blender.
That's the second
No.
time.
No.
Yeah.
It's a lame blender. Which one holds more liquid? Cylinder or goblet? And we are definitely thinking the goblet holds more. So compare the two, and goblet's 141. Goblet holds more liquid. Part B. If the second glass was half full, how high would the liquid be? If the second glass was half full, how high?
3 inches? No. No, it'd be 3 because it's half right there. 3. It's half full. It would be full. 3. 3. It is halfway on the thing.
We're gonna pause here because I want to give you guys time to work on bronze. We might come back to this one on Wednesday.
Because you didn't want to do one.
We only have 12 minutes left. You got 30 seconds. Point to your 1 o'clock. Go.
I am. Wait, no, I want the one that's there.
Do these all go to one place? Like if I go on Square and I get them out, would you be able to share it like collaborate it in the form? Okay, and then I can check those things and if not, okay, that's easy.
Do you have access to that form?
I don't have access to the actual spreadsheet.
I'll send you the test.
Okay.
Yeah.
If you add me as a collaborator, I can see the answers too.
The answers are there's one with answers and one without answers. So let me so here's what I'll do. I'll send you the test and there's a form that turned
Yeah.
Did she want us to do yours?
No, I just want to make sure they did it. Because if not, I can get the test. Send me the test too.
Oh shoot.
Because I just gave them my students for the week.
I don't have a way to see.
Oh, that's easy. Okay, that's easy. So if they take it, they should just push it.
Let me send. Cause like, see the problem is like if you didn't keep scratch paper, there's no way of knowing unless you go this whole process.
Robbie forgot me one year. Try that. So in like March, I think he was like, "Oh, I'm so sorry," and I had to. So don't worry.
I'll just share
He's
both.
okay.
And then, did they say they took it? Like, are they for sure?
No. That was starting with us, and two of them were chronic absences, so I'm pretty sure they wouldn't have.
Okay.
And then the
Yeah.
third might have.
Let me share you just the whole email. I'll just forward you it. And I need to have June just add you as a math teacher. Like next year, you should just be inserted in the email chain so that you're.
I think
It's kind of ridiculous.
And then when I on your guys'